house control. We do inside-outside the birds wash using antimicrobials. We have a chilling process, we're using antimicrobials. In the European countries, they don't do that. They rely on pre-harvest control, which is using vaccine. But the vaccine is not very effective for Campylobacter. It may be good for Salmonella, but not very good for Campylobacter. Also, they do the air chilling. And they do not use antimicrobials sometimes. So that makes it a little bit difference. Okay, I don't know the story at Australia. It's kind of like an isolated place, but just want to let you know their percentage is very high. How about in West Virginia, what we do? Earlier we mentioned there is a 78.1 million birds produced in West Virginia. So West Virginia Department of Agriculture and the Farmers Market Association in Charleston, they try to let you do is mobile poultry processing unit. This is an example. That's open air mobile poultry processing unit. It is about $30,000 for the one unit. 90 birds per hour can process. On farm can do 50 to 300 birds per batch. What's the problem for the open air MPPU? Not all the wastewater captured. The surface partially can be cleaned. Not everything can be cleaned. So one of my job is to developing a sanitation standard operation procedures for the MPPU. And I just come out with a menu for them to do, which is required by the small producers in West Virginia to using the facility. They have one facility at Charleston, another one at Berkeley, another one, Bakery, another one is try to move one at Morgantown. Enclosed MPPU. This is very similar to the one in our poultry farm. It's expensive, $90,000 for the units. Process 120 birds per hour, one batch 200 birds. This has to be usually certified by USDA FSIS. That is United States Department of Agriculture for the Safety and Inspection Service. The advantage to using enclosed MPPU is wastewater and solid waste collected and more surface clean. This is how the mobile poultry processing unit is going to go. This is I worked with Dr. Joe Motz a couple of years ago. We took the picture. So first of all, we have this trailer. This trailer can go anywhere. Okay, you just put a machine there. You put it at the back of the truck, you can drive anywhere. So the first thing what we do on the top is we do the bleeding. We call it exquisition, which means let's bleed it. And we are using like a knife, or we can using a stunning electronics stunning system. And you can see the cone there. That's very, very important to do the sanitizing, make sure there's no bleeding there. And then we put into the container, which is do the scottering. Temperature, we do 60 degrees Celsius, about 3 to 5 minutes. Then we do a dephasering, is in an automatic system. This dephasering machine is very difficult to do the wash, because lots of those plugs in. And after the dephasering, we do the evisceration. We do the manual evisceration. And this process, we cannot avoid it, microbial class contamination. More or less we have some, because the intestinal comes out. So that's why we have to do the chilling. The chilling is in a chilling tank with cold water, with ice. And usually the one bucket can put like 10 birds there. And there's we monitor the temperature, make sure it's 4 degrees Celsius or below that. And Dr. Joe Motz was using 5 parts per million chlorine. So that's what they use in this area. And after 24 hours, we take out the birds, we go to do a microbial analysis. And very lucky, the mobile poultry processing at WVU farm, we find a very limited amount of the salmonella. It's less than like 1%. So What's the major reason? Because mobile poultry processing, frankly speaking, in the university farm is much less frequently used compared to what we were using at the commercial. Because commercial setting, the mobile poultry processing unit is frequently used, and we don't have standards how to do the sanitation standard operation procedures. So we always get messed up, and lots of the positive samples will come out. And I can tell you, one thing, there is one place at Cheat Lake, it's at Deep Creek Lake, close to the border of Maryland. And we got birds from there all the time. And I just get 10 birds. I do the salmonella isolation. I can get 2 to 5 of them are positive. So what happens is later on, I use the birds in my microbiology class. Because every time when we go there, we get 5 birds, we can get 1 of them is salmonella positive. And the students in my class are very happy because we get to see the salmonella isolation. So I just want to tell you one thing, the pathogen control during those small producer processing is challenge and is also very difficult. Okay, one more thing. I haven't explained to you too much. How the weak acids work. So we want to explain to you how the weak acid is going to work. Okay. This is a weak acid. I'm using R to do the expression. Weak acid will have 2 parts. This is called undissociated. This is called dissociated. Remember, in the chemistry, we had a pKa value. That's a pH at which the concentration of undissociated equals the concentration of dissociated ions. Now, how do it work? This whole chemical, when they go to the bacterial cell, the only thing they can get in is undissociated one. And once they go into the bacterial cell, let's say this is a bacterial cell, then they dissociate it. And what they release is this proton compounds. These proton compounds will trigger ATP becomes ADP. Release phosphates. What this means? That means exhausting bacteria. Let the bacteria use energy. That is a basic principle for those weak acids, how they kill bacteria. So there's 2 things we want to say. Because this rely on the undissociated become a dissociated and release that hydrogen ions. So this chemical, lots of the time, it is only to do is inhibit bacterial growth. It's not killing bacteria. So we say it's a static, not realicidal, because in the acid environment, the bacteria always can resistant to it. We call it the acid adaptive status. The second thing is that because this pKa value restriction, so using weak acid, we have to make sure the pH of the products is close to pKa value. However, it is difficult to do because the pKa value lots of the time is 4.5-ish. It's relatively difficult to do. So that's why weak acid, like citric acid, lactic acid, acetic acids, basically how many logs they killing bacteria? About 1 log, about like 90%. They're not very effective. Peroxyacetic acid could killing bacteria 2 to 3 log. Chlorine could reach 2 log at least. Weak acids is only about somehow about like a log is the most. Okay, and also there are side effects. It will cause the myoglobin, affects myoglobin of the skin surfaces. Sorry, not the skin surfaces, the meat products. It will cause like a discoloration. So weak acid is not used too much in the produce, in the poultry meat industry. Okay, so this is all I have. Next week, Tuesday, we will move on to talk about overview food safety in the United States. Then we have a review on next week, Thursday. We will prepare for the exam 3. Okay? After that, April 10th, we don't have a class. It's just a research day. I was on the committee. I'm going to be working whole day. Then we move on to guest lecture and the presentation. Then finally, we have 2 labs. Okay, that's all the plan.